Hello, welcome to video lecture. Myself, Sudha Malay, Assistant Professor, Department of Civil Engineering from Rohini College of Engineering and Technology, Kanyakumari. We are discussing about the theodolite surveying. The theodolite is the most accurate instrument designed for the measurement of horizontal and vertical angles and has wide applicability in surveying such as laying of horizontal angles, locating points on time, prolonging survey lines, establishing grades, determining difference in elevations. Measurement of horizontal angles. There are three methods of measuring horizontal angles. First one is ordinary method, second one repetition method, third one retraction method. It's the ordinary method to measure horizontal angle AOB. Set up the theodolite at station point O and level it accurately. Set the vernier A to the 0 or 360 degree of the horizontal circle. Tighten the upper clamp, loosen the lower clamp. Turn the instrument and direct the telescope towards A to bisect it accurately with the use of tangent screw. After bisecting, accurately check the reading, which must still read 0. Read the vernier B and record both the readings. Loosen the upper clamp and turn the telescope clockwise until the line of sight bisects point B on the right hand side. Then tighten the upper clamp and bisect it accurately by turning its tangent screw. Read both verniers. The readings of the vernier which was initially set at 0 gives the value of the angle AOB directly and that of the other vernier B by deducting 180 degree. The mean of the two vernier readings gives the value of the record angle AOB. Change the phase of the instrument and repeat the whole process. The mean of the two vernier readings gives the second value of the angle AOB, which should be approximately or exactly equal to the previous value. The mean of the two values of the angles AOB, one with face left and the other with face right, gives the record angle free from all instrumental error. Then second one is repetition method. This method is used for very accurate work. In this method, the same angle is added several times mechanically and the correct value of the angle is obtained by dividing the accumulated reading by the number of repetitions. So the number of repetitions made usually in this method is 6. 3 with the face left and 3 with the face right. In this way, angles can be measured to a finer degree of accuracy than that obtainable with the least count of the vernier. Repetition method. To measure horizontal angle by repetitions, set up the theodolite at starting point O and level it accurately. Measure the horizontal angle AOB. Loosen the lower clamp and turn the telescope clockwise until the object A is sighted again. Bisect B accurately by using the upper tangent screw. The verniers will now read twice the value of the angle now. Repeat the process until the angle is repeated the record number of times, usually 3 times. Read again both verniers. The final reading after n number of repetitions should be approximately number of repetitions multiplying by angle. Divide the sum by the number of repetitions and the result thus obtained gives the correct value of the angle AOB. Change the phase of the instrument. Repeat exactly in the same manner and find another value of the angle AOB. The average of two readings gives the record precise value of the angle AOB. Then third method, retraction method. In this method is another precise and comparatively less tedious method of measuring the horizontal angles. It's generally preferred when several angles are to be measured at a particular station. This method consists in measuring several angles successively and finally closing the horizon at the starting point. The final reading of the vernier A should be same as its initial readings. If not, the discrepancy is equally distributed among all the measured angles. Then procedure is Suppose it's a record to measure the angles AOB, BOC and COD, then to measure these angles by repetition method. Set up the instrument over station point O and level it accurately. Direct the telescope towards point A, which is known as referring object. Bisect it accurately and check the reading of vernier as 0 degree or 360 degree. Loosen the lower clamp and turn the telescope clockwise to sight point B. Exactly. Read the verniers again and the mean reading will give the value of angle AOB. Similarly, bisect C and D successively. Read both verniers at each bisection. Find the value of the angle BOC and COD. Finally, close the horizon by sighting towards the referring object, that means point A. The vernier A should now read 360 degree. If not, note down the error. This error occurs due to slip, etc. If the error is small, it is equally distributed among the several angles. If large, the reading should be discarded and a new set of readings be taken. Then, the vertical angle measurements. It is an angle between the inclined line of sight and the horizontal. It may be an angle of elevation or depression according as the object is above or below the horizontal plane. Set up the theodolite at station O and level it accurately with reference to the altitude bubble. Set the zero of vertical vernier exactly to the zero of the vertical circle. Clamp the tangent screw. Bring the bubble of the altitude level in the central position by using clip screw. The line of sight is thus made horizontal and vernier still reads 0. Loosen the vertical circle clamp screw and direct the telescope towards the object A and sight it exactly by using the vertical circle tangent screw. Read both verniers on the vertical circle. The mean of the two vernier readings gives the value of the record angle. Change the face of the instrument and repeat the process. The mean of the two vernier readings gives the second value of the record angle. The average of the two values of the angles thus obtained is the record value of the angle free from instrumental errors. Thank you.